What's up, everyone? I'm the Nature Hacker, and this is your world. So today I want to talk about MOVI or MOVI fusion. So if you've been listening to me before, listened to the last interview, you should have gotten a good understanding of my idea of a new type of cold fusion. Basically, it's catalyzed fusion. I mean, cold fusion is just catalyzed fusion. We know the fusion can happen at high temperatures and with lots of energy input, but there are such things as catalysts, and catalysts reduce the activation energy required for a reaction. And yes, fusion is a reaction. Therefore, I believe it's chemistry. Physics doesn't deal with reactions, let's be honest. Okay. So, it doesn't deal with, I guess you could say it deals with mechanical reactions, but, where things are, it's hard to say, okay? It's hard to say. But anyway, the physicists want fusion to be physics, and the chemists would like fusion to be chemical. I don't have any particular bent either way. I consider myself an expert in both chemistry and physics. I enjoy both of them, but I do feel that this is more of a chemical process. We're dealing with electrons, so I believe it's chemical. Anyway, what we have now, I have a new idea, okay, and I want to give you the end from the beginning. The new idea is that before I said that it was probably electrons that would fill vacancies in a crystal structure, oxygen vacancies in a crystal structure. You've got hematite where it's got 3 oxygens for every 2 irons in the crystal lattice. They're all bonded together, like a crystal lattice. I said that, okay, we're going to create oxygen vacancies. We're going to rip some of those oxygen atoms out, and that's going to cause the structure to wobble, kind of like a Jenga thing going on. So now those irons can get closer together. There's no nucleus in there. There's no oxygen nucleus in there to prevent them from getting closer together. But they're still going to repel each other because it's the irons are positively charged. So they're not really going to want to squash down on each other. It might be a little more wobbly with that oxygen gone, but it's still not going to want to collapse in on each other. And I was saying that I thought that electrons could fill the spots of those oxygen atoms. And now that is kind of an odd thing to say because those oxygen atoms are pretty darn big with their nucleus. Compared to an electron, those oxygen vacancies are ginormous compared to a free electron. How is a free electron going to stay in that spot? And it would be pretty difficult for it to stay in that spot. And I think that the guy that was interviewing me, GeoStrubber, I think he was right in saying that hydrides can have electrons fill those spots, but not really other things. And actually, when I come to think of it, I think the paper I was reading about electrons filling vacancies was actually a paper talking about hydrides. So it is possible, but it's going to be very improbable unless you have hydrides, and which is interesting because hydrides are also what Pons and Fleischmann use in their cold fusion experiment. Their cold fusion experiment was done with like a couple volts. I think it was like 1.5 volts or something, but it did work because they were using basically hydrides. All right, now, so what the hydrides does is it acts as a catalyst and allows fusion to happen at much lower energy levels. But people can also get cold fusion to happen without any hydrides, nothing special, just 250 volts. If you use 250 volts, you can get cold fusion. It is kind of warm, but you get cold fusion at 250 volts without any special catalysts. And when you are using special catalysts, you only need like 1.5 volts is what Fleischmann and Pons did. But we're talking about something different. We're talking about that was all R-type. I believe it's R-type or it's N-type or something like that. It was rapid fusion. It's fusion of light elements that release energy when they fuse. It's much easier to do. What we're doing here is we're trying to do much more difficult fusion, and that is S-type fusion, slow-type fusion, the stuff that stars really can't even do. I just looked it up the other day, and the sun can't make gold. So we're doing something potentially here that even the sun can't do. The sun in all of its glory and strength can't even make gold, but that's something that I believe happens on Earth. Earth is where gold is created, in my opinion, and according to my theory. So obviously I just want to reiterate again, my theory is that gold is created in the Earth through a process that involves several elements, those including sulfur, hydrogen sulfide, hydrogen telluride, quartz, hematite, iron 2, oxygen 3, iron 2, or iron 3 oxide. So that is a process I believe creates gold. So, like I said before, what happens is you get oxygen vacancies occurring on the positive side. So let's say you have 2 electrodes with iron oxide, hematite in between it. Let's say this is the positive electrode. We got oxygen vacancies happening. The positive electrode is sucking out the oxygens from the structure, sucking those oxygens out, because oxygens are negative. The positive electrode is sucking those oxygens out like a vacuum cleaner. Okay, now you got this crystal lattice of iron oxide that is deficient in oxygen atoms. Now, what happens is those deficiencies, those little holes, those little gaps, what they're called is vacancies, they are positively charged relatively. So they're going to migrate over to this negative electrode. The negative electrode's like, hey, I got negative charges. Those vacancies are going to migrate towards the negative electrode. Now, what I thought before is once they got to the negative electrode, that what would happen is those electrons would fill up those vacancies. And then now we had that wobbly structure of irons and there's no oxygen in between. When you have an electron in there, now the positive charges on here are no longer repelling each other. Now they're both sucked into that electron and it implodes. It's a crystal lattice implosion. That's why I came up with the acronym MOVI or MOVI, however you want to say it. Muon oxygen vacancy implosion. Muon oxygen vacancy implosion. Those oxygen vacancies are going to implode when there's a muon that fulfills that oxygen vacancy. Now, what's interesting is, I was talking in the comments about catalysts and enzymes and things like that and how it lowers the energy required for reactions. I was like, I wonder if anybody has, talked about catalyzing nuclear fusion, like actually lowering the activation energy for nuclear fusion. And obviously I know that what Fleischmann and Pons did is catalyze nuclear fusion. That's how they did it. It was a catalyst for nuclear fusion. But I was like, well, I just wonder if this term has ever been used, catalyzing nuclear fusion. And indeed it has. And interestingly enough, what they use to catalyze nuclear fusion, besides Fleischmann and Pons, this is more mainstream stuff, is muons. So muons are like, you can kind of think of them as like giant electrons. Okay, they're electrons that are more on the scale of atoms. Okay, they're still small, but they're like, they're a few hundred times bigger than an electron. So that would make more sense. You got something more substantial that could go and stick in that oxygen vacancy. And what's really interesting is these muons are actually already used to catalyze fusion. So we know that muons can catalyze nuclear fusion. So this just fits into our theory just like a glove. Fits perfectly in there, perfectly in that oxygen vacancy, and also perfectly in the theory. And this would be how the collapse is caused, is you capture a muon in that oxygen vacancy. You know what's interesting? Muons stick in oxygen vacancies. It's known that oxides stop muons. Muons cannot be stopped. Muons will go straight through you. Muons are way crazier than neutron radiation. They're crazier than gamma radiation. They go straight through stuff. They will go through like, I don't know, hundreds of feet of rock, and stuff. You can't stop these things. But what does stop them is oxides. And the reason they get stopped by oxides is because the vacancies. They get stuck in the vacancies. They love the vacancies. And what's interesting is when a muon catalyzes nuclear fusion, this is known, muon catalyzed fusion is known. When a muon catalyzes fusion, that muon can be reused. Oh my gosh, that muon can be reused. That solves the mystery in my mind. I've seen hematite nuggets, not with my own eyes, but I've seen pictures online. Hematite nuggets with a spot melted on the hematite nugget, okay? A spot of gold melted into the hematite, which was crazy. And that makes me think, that had made me think from a long time before, that what's happening is, remember how I called it before nuclear melting? Nuclear melting, it's as if the hematite melted into gold, like with a literal melting type thing going on, because you know what I mean. It's melting, and you know how melting, you melt something and it like melts into something, you know? That's what it looked like. The gold looked like it was melting into the hematite. So that's why I call it nuclear melting before. But now this explains it. This explains that meltingness. The muon can be reused, which means the muon will make a collapse in this part of the structure, creating a gold atom. That muon will go to the next thing, create a collapse, go to the next thing, create a collapse, go to the next thing, create a collapse. That's a melting process. That's a chain reaction. It's not like an exponential chain reaction, but it's going from one to another. It's chaining a reaction, and that's where you would get a melting looking of gold. You know, we don't see gold as teensy. We don't see single atoms of gold spread throughout the hematite. No, we see a melted section of the hematite as gold. So this would explain why, is because that muon is getting reused and melting more and more of the structure. Okay, so wow, that's pretty amazing. So it's definitely these muons, I believe, causing this melting, this chain reaction. Muon, oxygen, vacancy, implosion, fusion, MOVI fusion. That's what I'm going to call it from now on, unless I come up with something better. But MOVI fusion, so that's how it's happening. Now, the question now, I think it's pretty obvious that, you know, a muon, which is, you know, a negative charge in that oxygen vacancy, can and will cause, at least catalyze, the combination of those iron nuclei into each other. It's reducing the activation energy required to collapse the nuclei and create a higher atomic weight element. At the very least, we can say that. I mean, I don't think anybody can disagree with the fact that if we have a muon replacing oxygen in a crystal structure, that will reduce the energy required to compact the nuclei onto each other to create fusion. I don't think there's anything anyone can disagree with that, okay? Maybe they could say, oh, it's not going to happen, or it's not enough energy, or the crystal's going to hold, the other bonds are going to hold it back, the iron's back from collapsing in. They could say something like that, but they can't say that it won't reduce the energy required for fusion. It will reduce the energy required. There will be less energy required to fuse those iron nuclei than if there was an oxygen in between them. Okay, I don't think that can be debated. Now, whether or not it can happen or whether or not it will happen or whatnot is up for debate, but you know, at least we have that point. So I think that's pretty much it. I mean, the muon gets stuck in oxides. We know that. The muons get stuck in oxides. You can look that up. Type in muon oxide in Google. You'll see that muons stick into oxides. Oxides can block muons. And what happens is those muons get stuck in the oxygen vacancies in the oxides. I believe I kind of saw something of that nature in the research when I was browsing it. But regardless, we know that that's going to happen, okay? You know, if there's a positive spot in the oxide, the muon's going to get stuck there. I mean, that's just obvious, okay? So, anyway, muon, oxygen, vacancy, implosion. The muon goes in that vacancy, causes the implosion into a new nucleus, gold, in our case of iron. So, yeah, now, you know, there has to be radiation going on. There has to be radiation. You know, in order for us to get iron 55, we're going to need some neutron radiation going on. In order for us to get muons, we're going to need some radiation going on. Radiation has to be happening. Whether or not that radiation is created in the process or a prerequisite for the process to happen, I don't know. I would hope that the muons and the neutrons, and by the way, when a muon decays, it releases a neutron. Okay, so that could be where the iron 55 is coming from, is muon decay, creating the neutrons which create the iron 55. Okay, it's this cyclical process of muons creating neutrons, which create iron 55, which creates the ability for there to be a collapse, which creates, gold, blah, blah, blah. So we've got to have radiation. So if something's working, we should see radiation. We should see some neutron radiation. We should see muon radiation, which is going to be really hard to discern. I believe there's gamma ray radiation involved in muon decay. I believe it releases a neutron. Gosh, maybe it doesn't release a neutron. It releases neutrinos. We know it releases electrons. That would be beta radiation. So maybe we should see beta radiation there. I don't think it releases neutrons, actually. I think it releases neutrinos, which would be harder to detect. But I do believe it also releases gamma rays. So we should see some beta radiation. We should see some gamma rays if this is happening. Now, I would hope that we have our two electrodes, positive electrode, negative electrode. We put a very high voltage there. We get oxygen vacancies happening on the positive electrode. We got the oxygen vacancies moving to the negative electrode. And hopefully there, somehow, we get muons created. When those muons fill the vacancies and they cause a collapse, which causes a chain melting reaction through, and hopefully turns everything into gold. Wouldn't that be nice? It probably won't turn everything gold. We'll probably get a little area of gold around the negative electrode is what I would predict. We get a little melt area of gold around the negative electrode. But that is probably what will happen. But the question is, how does the muon get created? It's like we answered 5 questions with the muon theory, with the muon hypothesis, the muon idea. This isn't necessarily a theory. What this is a theoretical framework that could possibly explain my theory. My theory is that gold is created with quartz, hematite, hydrogen sulfide, and or piezoelectricity from compression during earthquakes. That's my theory, is that gold is created in that process, okay, in the earth. Okay, that's my theory. Now this muon oxygen vacancy implosion idea is a potential theoretical framework that would explain my theory, okay? That would explain my theory, but it's not necessarily a theory on its own. This is a hypothesis. This MOVI, I like calling it MOVI, it just sounds cool. It's kind of like Mogwai or something. The MOVI idea is a hypothesis, and it needs to be proven. It needs to be proven that, but I believe it is commonly known that that muons do fill oxygen vacancies. The question is whether or not they can cause a collapse in the oxide structure. And the other question is, how are we going to produce these muons? So I need to do more research. Can high voltages produce muons? One thing I'm looking at is lightning. Do we see muons associated with lightning? One thing I've seen in the research is that storms can stop muons, probably because some type of positive charge is going on. I mean, the cloud is known to be negative. With relation to the Earth. So, it's hard to say how the muons get stopped by a negative charge. Maybe it's a repulsion. But usually you would think that they would get stopped by positive charges like oxygen vacancies, things like that. But they say that muons, can get stuck in thunderclouds and stuff. So it's hard to see. But what I would think is if we're creating muons in our electricity protocol, that 3 million volts or whatever, if we're creating, if we have 3 million volts here, my hope is that we're creating muons and therefore creating neutrons and types of radiation that can cause this to happen. But I don't know yet exactly how the muons are created. There is a process that muons are created in the atmosphere from I can't even remember what creates muons in the atmosphere, but you can look it up. Just type in Google, how are muons created, and you'll see, the cascade through the atmosphere and how that's created and stuff. But there's got to be another way to create it. Hopefully, with a high electric voltage, we can create muons, fill our oxides, and create implosions for muon, oxygen, vacancy, implosion, fusion. Thanks for watching. I am the Nature Hacker. Let's do some research. Let's do